this problem's for you. All right, anyway, so we're now going to look at a problem which you're going to see very similar in the homework. A runner is running with scissors and speeds up from rest to 8 meters per second in 3.2 seconds. What's their acceleration? What's their average velocity? How far did they go? And how fast was he going 2 seconds after that time? So let's talk about Jafit and what this is potentially going to look like. The first thing I want to mention up here is this. There are numbers in a physics problem that are not numbers. What number is in this physics problem that is not an actual number? Rest. And that word is going to come up a lot. What does that tell you?
Zero.
Is what?
Acceleration.
No.
Velocity.
More specifically.
Position initial?
Is velocity changing?
No.
Is velocity. So try again. Look at the problem. Starts at rest to 8 meters per second. To say that that's the velocity, well, this is a dumb problem then because he's just staying at 0, right? He's increasing speed to 8 meters per second.
Position or velocity.
There it is. So to separate between constant velocity and different, we just put subscripts on it to say it's changing. So that rest is velocity initial is 0 meters per second. What is that 8 meters per second? That would be velocity final, the velocity at the end of this section. And finally, that 3.2 seconds is your
Tunnel.
A lot of times in physics, you're going to get multiple part problems, okay, like this one. Almost always, very few exceptions, they're all intertwined. So that doesn't usually mean you need a new given and find for every different section. You usually have one big given and find. If there's new information given, absolutely write it down. But you're usually good for given and find on that. Now, part A asks me for acceleration, given, find. Then I write my equation. Always write your equation before you start numbers. Next part of Jafit's is algebra. Do I need to do algebra here? Absolutely not. I don't need to do algebra because A is already solved for. Now, plug in. There is a small thing that I don't know if other math classes or whatever do, but physics does this all the time to make things easier, and that is when you plug in a 0. When you plug in a 0, rather than actually put it down here, what you usually do is you go up to the equation and you go, that's a 0. The reason why is when you plug in zeros early, a lot of times it's going to make your algebra a lot simpler. We'll see that later. You don't have to do this. You could plug the 0 in just kind of as you standard would. But this is going to put us at 8 meters per second over 3.2 seconds. What's that answer? Come on, guys. We got calculations. We got things to do. Let's go. You're not just watching me. You're actively doing it. It's 2.5 what? Oh, try again.
Seconds squared.
Correct. Meters per second or meters per second squared. Now, somebody asked this last hour, so I'm happy to go over if you need. Somebody was like, why did the seconds not cancel when it's just meters? Are we good with that, or do you want me to go over it real quick? Good. Moving on then. Next one says average velocity. Now, if you write down the equation that you know for average velocity, you will quickly be irritated and go, I can't use that equation. Why can you not use that equation?
Because that's average velocity. Well, wait,
Sure.
no.
But it's asking for average velocity, so I think that's cool. Why can't I use that equation? I don't know displacement. So I can't use that equation, and that would get you stuck until you remember back to an example I did over here where I was walking at 2 meters a second, 2 meters a second, then 0.5, and 0.5, and 0.5, and then a particular point to point out that you can't take 2 and 0.5 and divide them and get 1.25. Why couldn't you then? It wasn't equal amounts of time. But if this is a constant acceleration, which we assume in this class that acceleration is, then this is what your graph actually looks like of velocity over time. It starts down here at 0, and it goes up here to 8 at a steady pace. The average would sit right here in the middle. Is there an equal amount of time before and after? So can you take both of them, add and divide by 2 now? Yes, you can. Now the equation that you're looking for that you technically have that is sort of new but not really is this. Average velocity is velocity initial plus velocity final divided by 2. What's velocity initial?
0.
So this is just 8 meters per second divided by 2, or this should make really good sense. The average velocity is 4 meters per second. Right there in the middle between the 0 and the 8, and it steadily rose. Half the velocities are less than 4, half the velocities are greater than 4, so I 100% can use that average. Now the next part of this asks, how far did he go? But if I look at this equation right up here, the equation for acceleration, I don't have displacement in that at all. But just a second ago, I had this equation over here, and I told you we couldn't use it because we didn't have displacement. But do we now have average velocity?
Yeah.
So can we use this equation now to get displacement?
Yes.
100%. Now I do have to do a little bit of algebra. My algebra, if you struggle with algebra, use all the steps. If you're like me and you're pretty good with algebra, here's what I want. I want the original equation. Boom, I multiplied both sides by delta t. I'm done. I'm done because delta x is by itself. Average velocity is 4 meters per second. Time is 3.2 seconds. So doing this quickly in my head, that's 12. It's 12.8 unless somebody check me to make sure I'm right. Sweet. Seconds cancel. We're at 12.8 meters. Questions on that so far? Yes, Brandon.
So, how'd you go from 2.5 to, how'd you go from the step where you had A equals 8 over 3.2 and solve for 2.5 meters per second squared? to
These are
the-
separate things, by the by.
Yeah, how'd you get the 2 underneath? Where'd that come from?
How did I get what?
The 2, it's all over 2.
Average. There's 2 of them.
Oh, duh.
Add them all up and divide by 2.
Okay, got it.
Yeah, I mean that's what you did with the 2 and the 0.5 and got 1.25. You just couldn't use it there. Yeah, this is just the mathematical
Okay.
representation of finding an average. Yes.
And
How
then
do you find displacement?
Displacement was using this equation where I couldn't use this equation to get average velocity because I didn't have displacement. I do now know average velocity is 4, so I'm rearranging this. This is just multiply delta t, displacement equals average velocity times time. So I'm using the average velocity here and the total time here to get displacement. Last step up here is, hey, how fast was he going after 2 seconds? Okay, well, after 2 seconds, that's my new variable, so I should probably put that in terms of time, and I'm going right back to this equation. What about this equation has stayed the same, and what about this equation has changed from my very first part of the problem? Yes?
Everything should be the same except for delta t, right?
There's one other thing that should be different, obviously. Well, not obviously. Acceleration absolutely should be the same, so we already know it. Okay, VI still starting from 0.
Oh, VF.
Correct.
VF.
Obviously, we're trying to get the new VF. So this 2 seconds, by the way, in case you're confused, is somewhere between the 0 and the 3.2. So we're using the acceleration that we know. Now, algebra. Once again, here's the algebra that I'm going to show. Feel free to do the same. I write the original equation, always. Boom, I've done algebra. Now, if you need to show the steps, please feel free to make sure that it's accurate. This is all I'm going to do. That's all I expect you to do. So that would be 0. That would be, what, 2.5 meters per second squared times 2 seconds is, the answer should be 5 seconds. 5 meters per second, rather. Now, if you want to show that algebra, because you didn't follow me doing that real quick, here it is real quick, but let me also talk about what steps I skip over here in algebra. And that is usually, when you did algebra the first time, it's show delta t multiplying and show delta t multiplying. I don't need that if you can do it in your head. So I'm going to multiply delta t, cancel it here, and this is going to be a delta t. And now to get VF by itself, I'm going to add VI on both sides, cancel, add it over here. And if you feel so inclined that you want VF on the left side, great, rearrange it. But I don't need you to do that. That'll still get you the right answer. Questions, concerns? This is what I'm looking for on your homework. As long as you're trying to do Jafeeps, we'll work through that. If you ignore Jafeeps entirely, you're going to be redoing the problems. All right.